again. In this video, we'll talk about the three conditions for mnemothetic causality. That is, what are those three conditions that can help us establish if a variable causes another variable. In the previous video, we discussed that there were three conditions. The first one is that there is a relationship between the two variables, a statistical relationship between the two variables. The second condition is that the cause takes place before the effect and not the other way around. And the third condition is that we need to show that there is no third variable that is explaining this relationship between these two variables as spurious. Now, let's look at each of them separately. The first one is that we need to prove, in order to say that a variable causes another one, that x causes y, for example, that there is a statistical relationship between them. And by statistical relationship, we mean that changes in one of the variables are associated with changes on the other variable. That means that particular attributes of one variable are associated with particular attributes of the other variable. And not only this, but also that the observed association is not there just by chance or sampling error, as you will see later on. Let's look at an example. Let's say we can observe 8 individuals. Let's say these are a sample of the population. And for each individual, we observe whether they have a condition present or not. This condition X, 4 individuals have it, 4 individuals don't have it. And for each individual, we also have information about certain outcome Y. Whether they have it or not. Yes or no. So the first individual in that list, for example, he doesn't have the condition present, and he doesn't have the outcome either. The second individual in the list doesn't have the condition present, but does have the outcome. Now, if we tabulate these results in the table on the right, we will see, if we're looking at the columns, that when the condition is not present, people tend to not have the outcome Y. 3 of them did not have it. But for people who have the condition present, most observations do have the outcome Y. So as we're moving from the condition from not present to present, we see that the outcome is more likely to become yes. For those who have the condition, the outcome is more likely to be yes. So if we change values of X, we observe a change in values in Y. That means that there is a relationship between X and Y. Now, if we were looking and going back to our example of substance use disorders present at home and an occurrence of child abuse, right? And this is the same table as before. We may see that for when substance use disorder are not present, the condition of child abuse or the outcome of child abuse tends to be no. 3 no, 1 yes. But when we change to a condition of yes, there are substance use disorders present in the home, then child abuse is more prevalent there. There's 3 as opposed to only 1 that didn't. So as we move from not present to present in terms of SUD, we see that there is an increase in child abuse instances. So as we change SUD presence, child abuse occurrences change as well. So there is a relationship between substance use disorders present and occurrences of child abuse. That's what we mean by a relationship. Now, if we were looking at some other type of data where we have a condition Z and an outcome Y. Look at that tabulation on the right. We see that when condition is not present, we observe no, 1, and 3, yes for outcome Y. And when we switch it to the condition being present, we also have 1, no, and 3, yes in terms of outcome Y. So as we change from not present to present, outcome Y does not change. It's still 1, 3, 1, 3. When you change the values of one and the other one stays the same, then we can say that there is no relationship between these two variables. As we change Z, the values of Y remain constant, so there is no relationship between Z and Y. That is what we mean by an association. When we see that as we change values in one variable, we observe changes on another variable, we can say that the two variables are related, or that they co-vary. Some people say they are correlated. Now, when we see that this correlation or this covariation is not there just by chance, then we can say that this relationship is not only there in the sample, there is a statistical relationship. But don't worry about the statistical part right now. We will come back to that in a few weeks when we talk about hypothesis tests. For now, we have to understand that just because that when X changes, Y changes, we can say that there is a relationship between these two variables. Now, just because there is a relationship between them, that doesn't mean that X is causing Y. The statistical relationship is just the first condition of nomothetic causality. There's two more. But once we've established the first one, that there is a relationship, we move to the second one. The second condition says that we need to establish that the cause came before the effect. In other words, if X is causing Y, then we need to make sure that X came before Y. If there is a chance that Y came before X, then we cannot say that X caused Y. This seems rather obvious, but sometimes it's not. Let me give you an example. We observe that higher numbers of firefighters are associated with higher numbers of fires when we looked across different cities. Now, can we say that the number of firefighters is causing the fires to be more frequent? Or is it more plausible that the number of firefighters came after the fires? In other words, cities that had more fires hired more firefighters. So the number of fires was actually determining the number of firefighters and not the other way around. Now, if we cannot be sure of which one came first, then we cannot say that one caused the other, that the number of firefighters caused the fires. Let me give you another example. We observe when we compare people who finished college and people who did not finish college with a bachelor's degree. We see that people that finished college with a bachelor's degree are smarter than people who did not finish their bachelor's degree. Now, can we say that the bachelor's degree caused the higher IQ? Which one came first? Well, it could be that smarter people went to college in the first place, right? So the higher IQ is causing them to have a bachelor's degree and not the other way around, right? It could be that people that completed a bachelor's degree had a higher IQ than those who did not, even before entering college. So college did not cause the higher IQ. The IQ was already there. If we cannot be sure which one came first, then we cannot say that the bachelor's degree caused the higher IQ. And therefore, we cannot establish causality. But let's say we could. Let's say we find that there is a statistical relationship let's say we are sure that the cause came before the effect, we still cannot say that X caused Y. We still need to prove the third condition. And the third condition states that there is no third variable that can explain away the observed relationship as spurious. Spurious means that something is fake, that there is a coincidental statistical correlation between two variables that is caused by some third variable. Let's say we observe that X and Y are related, but we find out that there is a third variable that is causing both X and Y, in this case, to move. Let me give you an example. And this is a true story. We find that in a study in Chicago, they found that the number of books at home children had were associated with higher test scores for these children. They were asking, though the number of books at home caused the children to have higher test scores, they discovered there was a relationship, and the number of books came before the test scores. But the number of books were not causing the child test scores. It was a third variable that is explaining both. They hypothesized that this was parent involvement. Parents that were more involved were more likely to have more books. And parents that were more involved were more likely to have their children score higher on the tests. So parent involving was moving both of these variables. It wasn't that one was causing the other one. They were moving together because of this third variable. Other researchers say that the third variable in this relationship could be family income. Families that have higher income tend to have more books at home, and families that have higher income tend to have their children score better in tests because they have other resources like tutors, better schools, and so forth. So if we cannot rule out the possibility that there is a third variable that is explaining movement in these two variables, then we cannot say that there is a causal relationship between the two. So, those are the three conditions that we need to establish. If we want to say that X causes Y, we need to establish that X and Y are related, that there is a statistical relationship between them. 2, that X came before Y. And 3, that there is no third variable that is moving X and Y at the same time. Only if we establish these three conditions, only if these three conditions are met, that they are related, that X came before Y, and then there is no third variable, then we can conclude that X causes Y. Now, in class, we will give some examples about this. But you should go back and rewatch this video to understand what these three conditions mean. I'll see you soon.